Anything below 240, go on the 200 scale. Anything above 240, go on the 600 scale.
So if I was to do 200 scale and measure 240, I would know that.
Yep.
Cool. Thank you.
Yep, yep. So volts AC, one terminal on N, one terminal on L1, what do you get?
124.3. Volts AC.
So you have to select between 200, no, you're on volts. You want volts, that's AC. I'm trying to find more volts AC. You only have one scale. Mark, can I borrow this client? Yeah. Now, a couple of you guys that have probe holders on your meters. Anybody got a probe holder on your meter? So that your probe can stick out like this? The purpose of that is so you don't need three hands to use your meter. Alan was just doing like this. He had his meter over here, as far away from as possible. I'm going like that. Boom, now you can see what you're doing and what you're measuring at the same time with two hands. That's what your probe holder is there for.
And the client meter helps you out.
Yes. It is helpful, but that's what that little probe holder is for. So what are you measuring, guys? Let's write it down. Let's start off with this one here. What do you guys got?
Go with me. I got
Power on. Power switch. Close the power switch.
Oh, you need
Power on.
I got 125.6.
125.6. Alan, what you got? You got 126.3. And what's your partner got? What you get? 124. Same, both you measure the same thing, coming up with something different, right? What you got?
23.
123. Interesting point of fact, all three of these boards are all plugged into the same outlet, fed by the same circuit.
It could be the meter.
Zach, what you got in the back?
124.9.
24.9.
Such a board.
Andy, what you got?
124.5.
125.2.
And last but not least, what are you guys measuring over there?
125.0.
25.0. Are you both in agreement, or you got something slightly different between the two of you?
124.5.
The range of differences between different instruments. Not necessarily a right or a wrong here. However, the point here is that you get to know the instrument that's yours. Just like you know the back of your own hand or the front of your own hand. My stepdad was a real bad dude. And he always used to say, he really mean stuff like, I really like the back of my hand. I started looking at the back of my hand, I'm like, I realize I really don't know the Because different meters behave and respond differently in different situations. It doesn't necessarily matter if you have a super expensive meter or a less expensive one. As long as you learn how it behaves, you'll understand what it is that it's communicating to you. And most importantly, you're going to get to understand what the limits of that communication are. When you run into a situation where you need to invest in a higher quality meter. Alan, as a plumber, and if you're a plumber, I don't want to say this, if you're something that's not. The meter that you have right now for the types of measurement that you're going to run into most frequently is going to be perfectly adequate because you're looking to get a basic idea of current, basic idea of voltage. It's going to do that. It's going to be just fine. If you are trying to find an intermittent problem on a high efficiency variable speed two-stage furnace that only happens once every 3 weeks, you're going to need a little bit higher technology, a little bit more accuracy. In fact, you're probably going to need 2 multimeters so that you can know what's happening on this end of the circuit and that end of the circuit at the same time. So don't necessarily say, man, Eric said I've got a cheap meter, I need a new one. No, not necessarily. What you need to do is get used to the meter that you have and understand it. The meter that he's got, that is actually my most commonly used meter, and I only paid $70 for it. I understand that it's not that accurate though. And I've got my Big Daddy over here for when I really need to do some good work, but I get 80% of what I need to get done with that guy right there.
Most of the meters that I see in here are better quality than what the electricians use on a day-to-day basis.
Oh yeah. I'm sorry to say, but electricians are not electrical troubleshooters. I don't know you guys personally, but from my experience, the electricians that I have met and worked with, they just do not have electrical diagnostic skills or the meters or tools to be able to do it because they're involved in running wire, hanging conduit, and codes. Yeah, right. There's nothing wrong with that. But when it comes into the machine, they don't know what that thing is even supposed to do in the first place. So how are they even going to know where to start troubleshooting? It's just, yeah, that's cool.
And the power of these are
Kind of surprised I don't see more than here today. Anyway, questions about this? We all measure voltage. It doesn't matter what you get as long as you do this on a regular basis. Now, when do you want to be measuring what your supply voltages is? Here's a question. Here's something to think about. Do I need to know exactly what the supply voltage is if the machine is running?
Yes.
Yeah, I kind of do. Because it can be running, but it can be running with a reduced voltage, which will hurt it over time. Maybe not today, maybe next week, maybe next year. That's important. When we're doing troubleshooting, especially, I need to know exactly what the voltage is being applied to whatever I'm measuring. My motors, my loads, my circuit boards, all of these things have a very specific voltage requirement, plus or minus tolerance. If we're out of tolerance, that device will experience failure or a problem, especially if it's an intermittent problem. Nothing is worse than leaving the meter in the truck. It's like waiting to get until you're stuck in the ditch to put the truck in four-wheel drive. It ain't gonna help. You're already stuck. And start by taking voltage measurements first. Take them early, often, and regularly. Zach here mentioned taking amp draws on draft reducers. You're doing PMs, measuring this data over and over again. You might say to yourself, I keep getting the same thing all the time. Why do I need to keep measuring this? What is this telling me? Well, for one thing, it's telling you that you have what you're supposed to have. And then when you have something that is different than what you're supposed to have, you're going to be able to recognize it. If you hadn't spent all that time checking things that were normal, you wouldn't be able to recognize the abnormal thing. That's another reason why I do that. Any questions on this so far? Okay, so we actually have transformers hooked up to these things. We got power coming in. It's coming into our transformer. If you look at those wires coming in there. And then it's coming out of the transformer over here between R and C. So with power on, plug in, measure voltage between the R terminal and the C terminal. Seven-ish.
27.
What you got?
28.
Okay, 27. This is nominal 24 volts. Notice it's a little on the high side, and that's pretty normal. Most of our 24 volt transformers typically put out 28 to 30 volts AC, and that's what we expect to see. You guys remember earlier when I was talking about a limited supply of power?
Yes.
You guys over here remember we were talking about a limited supply of power? Remember when I said the concept of a limited supply of power was kind of difficult to grasp? Because when we plug into the wall, we pretty much have all the power we want for anything that we want it for. The transformer is a really good example of a limited supply of power. It's sending out voltage, but its ability to power devices is limited to its inherent design. We call that VA. We'll get more into VA later. But the voltage being present here, voltage is not necessarily a representation of power. The VA is a representation of power. VA is a mathematical equation. Mathematicians write equations, they don't bother with symbols like times and divide and plus and minus. They just put letters next to one another and magically know what it means. When two letters are next to one another, that means they're multiplied together. This is saying volts times amps. Volts times amps equals what? Watts. Exactly. When we're looking at a power source, a power supply, that calculation is described as VA. When we're looking at power consumption from an electrical device, we call it watts. It's really basically the same idea. So if this transformer is 40 VA, how many 5-watt devices could it potentially power?
8.
Potentially 8. Theoretically 8. If we connect 8 5-watt devices to this transformer, they will all run, but that is the maximum power output that transformer is able to provide. That would be very similar to running your engine on red line constantly. How happy do you think that transformer is going to be about that? Just about as happy as your engine is going to be running on red line all the time. It's going to shorten its lifespan dramatically. Instead, we would really prefer to connect no more than 5 or 6 of those devices to keep it well within its capabilities. So, now that we said all that stuff, I don't expect you to remember all that. Here's the part I do want you to remember. Those of you in boiler basic training, when you went through the zoning class, we talked about the amount of zone valves on the transformer. Got that part. When you have too much stuff connected to a transformer, or when one of those things that's connected to it is having a problem, causing it to try and consume more power than it normally would, the result will be the transformer will be unable to supply that level of power, and as a result, the voltage that it puts out will drop. It will suck voltage literally right down, because it's putting out as much as it possibly can, and when it gets overloaded, its voltage will drop. You will see this very rarely, and this is suddenly when it went from really basic to super advanced now. So some of you, this is going to go right over your head, and that's okay. Some of you are going to be like, that's what we were looking at when I was busting my butt in that crawl space for 6 hours. When there's no load connected, nothing is running, the transformer puts out normal voltage. As soon as something turns on, that voltage will drop to 19 or 10 or some ridiculously low number. What the heck? You're nodding your head. Have you seen something like that happen? Drives you nuts, doesn't it? Here's what's going on. The transformer is sitting there supplying voltage, but there's no current flowing. Something's wrong with whatever the heck it is that's turning on. Let's say it's a gas control valve, right? As soon as that gas control valve goes, man, the voltage drops to nothing, and then the gas valve just doesn't open, and the voltage goes back to normal again. That's irritating. Irritating, to say the least. Here's how you find that problem. You need 2 meters. If I've got a transformer over here, and I've got a gas valve over here, I want to have 1 meter monitoring the gas valve voltage, and another meter measuring the transformer output voltage. So my first meter right here is measuring transformer output voltage, and I want to have this thing set to record. If you've got a min-max feature on your meter is constantly looking at what it's seeing, and as soon as it sees a deviation from what it's seeing now, it will record it. It will record the highest value it sees and the lowest value that it sees, and will lock it into a hold screen. So once you're measuring voltage, you plug this thing onto automatic hold mode, or min-max mode, either one, whichever one you have. Then you have this one set up to just measure voltage. You're watching this meter